I'll walk you through Insight Solar Photovoltaic Training Kit. This training kit is an effort of Ecosense Sustainable Solutions to help you and your students to develop an in-depth understanding of photovoltaic plant through real-life hands-on experience. Let's start with the description of its components one by one. There are two subunits in this experimental kit. One is the main controller of system and other is photovoltaic power source unit. First, we'll see the features of main controller. It consists of a meter for temperature measurement, ammeters and voltmeters for measuring PV module output, inverter input, battery input and output, DC load consumption and AC load consumption. In addition to these meters, there is one charge controller for battery charging and DC load operation, one potentiometer for changing the resistance of the circuit, one inverter which is inbuilt in this unit, two batteries, and AC and DC load. These loads are lighting load which are set at the bottom of the controller. DC load is fixed in outer ring while the inner ring has the AC load. There are two diodes also which are inbuilt and can be taken in the circuit by using the ports of these built-in controller. At the backside of controller, there are two ports by which module output can be connected to the controller and can be utilized from the output ports which are at the front of the controller. There is a temperature probe which is coming out from the back of the controller, which is for the measurement of module temperature. This controller needs AC input for powering the meters, which is provided by the cord at the back of the controller. Now we'll see the other subunit, which is a photovoltaic power source unit. The stand supports the photovoltaic modules and the portable light source, which is a simulation of solar radiation. Intensity of halogen lamp's light can be changed by moving the regulator fixed at the lamp itself. Frame of module is attached with a gear mechanism which is for changing the tilt of the module. There is a protractor at the surface of the module to measure the tilt of module. In addition to these two subunits, there are connecting cables for making the connections, shading elements for shading the cells of module and module also, lux meter for measuring the radiation level on the module surface. Now we'll proceed towards the experiment details. The experiments are divided into two sections. The first section is related to photovoltaic module characteristics, which has 5 experiments. The first experiment of this section is about the characteristics of single photovoltaic module. For executing this experiment, we have to connect the ammeter and potentiometer in series of photovoltaic module power and voltmeter across the terminals of photovoltaic power. Now, by moving the potentiometer, we can collect different sets of voltages and currents and can plot a graph between these two parameters at a particular radiation and temperature level. Radiation level and temperature can be noted down with the help of lux meter and thermometer. This experiment will give the IV curve as well as fill factor of the module. The second experiment of this section is about the IV characteristics of two modules in series and parallel connection. For executing this experiment, we have to connect the modules in series and parallel alternately and follow the process of the previous experiment. This experiment will give the IV characteristics of series and parallel combination of two modules. The third experiment is to study the tilt effect on module's power. The connections in this experiment is the same as the previous experiment. By using the lever behind the module, we can change the tilt of the module. At different tilt values, we can record the module power by multiplying current and voltage. We can draw the curve of module's power versus change in radiation with tilt. The fourth experiment is to study the shading effect on photovoltaic modules. The connections in this experiment is the same as the previous experiment. We can put the shading elements onto the cells of a module and record the values of current and voltage with shading effect. The fifth experiment is related to the diodes, bypass effect and the blocking effect. There are two sets of diodes. The diodes can be connected in series or in parallel to the module output. The photovoltaic modules have to be connected in series. Shade one of the modules completely. To the shaded module, connect the diode in parallel. This experiment will help derive power losses when one module gets shaded completely without bypass diode. Putting diode in parallel to shaded module will reduce the power losses by shading. After this, connect the modules in parallel and shade one module completely. The current generated by the unshaded module will be dissipated in the shaded module. To avoid this power loss, put one diode in series with the shaded module in reverse bias mode so that it allows the current generated by unshaded module to flow in the circuit. This can be shown by using LED in series with the shaded module. Now we are done with the first section of experiments. The second section is related to the standalone system. There are 4 experiments in this section, which will help us understand the working of different components in the standalone photovoltaic system. First experiment in this section is about the demonstration of DC load in the standalone photovoltaic system. In this experiment, the module power output will be connected to the input of charge controller with ammeter in series and voltmeter in parallel. Then, output of charge controller will be connected to the battery and DC load with ammeter in series and voltmeter in parallel. The readings of various meters will be recorded to demonstrate the power consumption of the DC load and also the power loss in charge controller. The second experiment is about the demonstration of AC load and inverter efficiency. In this experiment, the module power output will be connected to the input of charge controller with ammeter in series and voltmeter in parallel. Then output of charge controller will be connected to the battery and inverter with ammeter in series and voltmeter. Output of inverter is connected to AC load with ammeter in series and voltmeter in parallel. The readings of various meters will be recorded to demonstrate the power consumption of the AC load, inverter efficiency, and also the power loss in charge controller. The third experiment is about the demonstration of both AC and DC load and inverter efficiency of standalone photovoltaic system. In this experiment, the module power output will be connected to the input of charge controller with ammeter in series and voltmeter in parallel. Then output of charge controller will be connected to the battery, DC load and inverter with ammeter in series and voltmeter in parallel. The output of inverter will be connected to AC load with ammeter in series and voltmeter in parallel. The readings of various meters will be recorded to demonstrate the power consumption of the AC and DC load, inverter efficiency, and also the power loss in charge controller. The fourth experiment is about the demonstration of battery characteristics. In this experiment, the battery will be charged through the charge controller and voltage of battery terminals will be recorded at regular intervals with the help of voltmeter across the battery. After this, battery will be discharged through the load and voltage of terminals will be recorded at regular intervals. A graph of battery voltage versus time will be plotted both for charging and discharging. This completes the demonstration of Insight Solar Photovoltaic Training Kit. This training kit can be used to educate engineering students in design and operations management of the solar photovoltaic system. It can also be used to train the vocational students in installation, operations and maintenance of solar photovoltaic system.